We were always looking for a way to get our hours down and maximize efficiency for the clients and stuff. So since I started that job, we started using serverless architecture. It started off just making some basic Lambdas, and then we started using other elements of the AWS ecosystem and their microservices, which actually saved us a lot of hours and let us do what we really wanted to do, which was make the application for the client better. So I'm pretty positive most of you know what a server is already. So the basic idea is that you have to not only write the code for the server, but you have to take care of the infrastructure and also manage it and worry about the RAM and the CPU and so many other configuration options when you're building a server. Even if you're using a virtual server where taking care of the physical aspect is abstracted away from you. So since December 2014, AWS came out with this new type of architecture for them, which they called serverless, which was functions as a service. So you're basically writing cloud functions or just writing code in these little modular blocks in the cloud, and all of the infrastructure and configuration is abstracted away from you. So the only thing almost that you had to worry about was just writing code in the cloud. And this gained popularity pretty quickly over the last few years because they say that, or AWS came out with their own statistics, so they say that most mature companies will spend about 25% of their time and resources for developers just managing their infrastructure and servers and things. So, yeah. So serverless is basically a way to start and build applications more quickly and also cheaply, pretty cheaply on AWS with having AWS manage most things for you. So here's the basic idea of it. You have a series of Lambda functions at your core, and then you have various event triggers which will make the container for the Lambda spin up and run. So the event triggers could be manual from your application with an invoke function, or they can be a number of different Amazon services that have one-click integration, where you can just choose which service you want to trigger the Lambda, and AWS will take care of the rest for you. And then your Lambda can do many things that normal servers would do. It can store in temporary storage, convert, interact with the database, send things back to the user. You can use cron jobs as Lambdas or set up an API with them. Lots of things that a normal back end of your application would do. Yeah, so these are some of the one-click event triggers. AWS keeps coming out with more. I think this was from reInvent 2016, so they have a couple more now. The most common ones are DynamoDB, their NoSQL database solution, S3, API Gateway, and SNS, which is their notification service. So there's a couple different ways to structure a serverless architecture, and I'm just going to use an API as an example. Nanoservices is very small modular functions, so if you had the user's endpoint, you would basically make a function for each method. So you would upload a different Lambda function or a different function that took care of handling requests to each different method. Yeah. Which kind of, it makes sense if you get a lot of hits to those endpoints, but the most common architecture is using it as microservices. So for all of your requests to a single endpoint, you'll use a single Lambda function, which, depending on how much your Lambda function is run, it does take like a minute to spin up in a containerized environment by AWS if you haven't used it in a while. So depending on how active it is, I guess that'll come into or be factored into how you configure your Lambda architecture. And then there's Monolith, which you don't really see too much, but it's basically making a huge Lambda function that takes care of everything in a single endpoint to to interact with the Lambda function. And you can see this example, GraphQL uses this. They have a single endpoint to handle all the requests for the backend. And serverless is not just for backends either. You can use it, people use it for anything that you might need compute or some kind of server to run in the cloud. It won't always make sense, but like these examples from AWS, these are the most common things people use Lambdas for. Yeah, the only difference is you're basically letting AWS manage all of the underlying infrastructure, and you're just worrying about the code. So, yeah, the basic benefit is that it's much easier and less time-consuming, and it's also very cheap. There's no upfront cost. You get 1 million free calls a month. And that's for the lifetime, not just for the free tier for a year. Yeah. And also, all functions remain stateless, so you'll store. It has a temporary storage only while it's running, but you'll store things in another storage, like S3 or a database solution on AWS or somewhere else. So it makes it easy to scale a lot of these functions at the same time. And AWS will automatically spin up as many functions as you need. And if you don't need, it's not like a regular server where you want as much uptime as possible. If your function isn't being called, it's not going to run and it's not going to charge you anything. So all these examples are in Node. I hope that's OK with everyone. I think it's definitely much easier to read than some of their compiled languages. So it's basically, if you've seen more modern modular syntax of applications, you have your imports and dependencies at the top. They could be either local dependencies, like things from NPM, or they can be other microservices from AWS, or any built-in modules to Node, which you have access to in the environment. And it gives you 2 parameters. The event gives you information about the event that triggered the Lambda to run. So, for example, if an S3 upload triggered the Lambda to run, you'll get information about what object was uploaded to S3, the name of the bucket, and different metadata related to that. And then the context, gives you information about other related services like CloudWatch and AWS, as well as some useful functions to call if the Lambda function fails or if it succeeds and things like that. Yeah, and also if you pass any data to the Lambda function, it's included on the event object. So here's just an example of what the event object looks like. So if, it's not scrolling with me. Yeah. So it'll give you all the information about the S3 upload that triggered the Lambda. And if you're resizing an image, for example, you could pull the name of the bucket and the name of the image and the path, and then know where exactly to store the resized image from, which is pretty cool that all of this stuff is just automatic. Yeah, well, I guess I'll show this, yeah. There's a couple different ways to debug on AWS, which I'll show in a second. They have a pretty good service called CloudWatch, which will show you any logs, errors, how long your function ran, the invocations. Let me see. No. Well, I guess I don't have it here, but I'll pull it up in a minute. And then you can also run it locally if you want to stream all of your Lambda events and know what's happening, or if you want to interact with their API and build your own kind of dashboard to view what's going on when you invoke the Lambda and all the other microservices together. So you can create your own metrics. And then if you're really, I guess, not serious about architecture, but if you want more options, they have some really good third-party vendors. This is just an example of one, but they have quite a few that'll give you some really good metrics about how your serverless application is doing. Yeah. And then for testing, so it's just functions. So you can use any unit testing framework that you normally use to test the functions. In JavaScript, I usually use Karma, Mocha, Expect, or Jest. And each language has their own pretty good frameworks that you can use for testing. And then live testing has always been a little bit more difficult, just because you need some other elements of the infrastructure sometimes to test your functions. So you can automate the zipping and uploading of it using a framework. They have some command line tools now. August 11th, AWS rolled out a new feature to test it locally that I haven't tried yet, but I'm excited to try that soon. I've been waiting for it for a while now. And then, yeah, so the idea is that you will develop these offline and hook them up to Git and to your CI/CD, and AWS offers you a lot of other tools to help you set up CI. You can also integrate it with any other development or integration that you already have, like GitLabs or something. So, oops, I'm just going to show how this is in code. Let me mirror my screen real quick. Okay. Oh, I have it here. Okay. Here we go. So this is the AWS console. I'm not going to show you how to sign up or anything. It's pretty straightforward. It takes a few minutes. So it gives you the option to create everything in their Cloud GUI. You can create a new function. They give you a lot of blueprints too, in 4 different languages: C#, Java, and then they'll configure all the classes and folders you need for it to compile. And then they also have Python and Node. So I'm just going to do Node. I can always configure triggers later. So it gives me a basic function off of the bat that I can use and test. And then there's quite a few different, they are slowly adding more configuration options that you can do. But the 2 main ones are the memory, which is proportional to CPU, and the timeout. So functions are failing a lot. Usually it's because the timeout is set too low. You can do anywhere from, I think, 1 second up to 5 minutes. And it's billed in 100 millisecond increments from execution. So I'm just going to leave it like that. Click Next. Oh, I have to choose a role. Roles are what give you permissions to access different things in the AWS system. I'm logged in as the root admin right now. So, but for this Lambda, I'm just going to choose a basic role, so it's not going to have access to everything on AWS. It's an existing role. You only need access to Lambda and CloudWatch, which is what it uses to log out events. Lambda basic execution. Oh, I didn't put a name for my function. So I remember and can delete it later. This isn't my main account. It's a hackathon account, so I can mess with it. All right. So it created my function. and I can test it right in the browser and spin it up. It gives me some default test events. I can configure any JSON object to test the function with. And the first time it takes a little bit longer, but not too long. And then it gives me details about how long it takes to run. Again, this is just because it's spinning up the initial time. If I did this again, it would probably take about a few milliseconds to run because it's really not doing anything. And then the callback gives this information. That's the information that it sends back to the user. I don't know if I mentioned this, but this is an optional third parameter if you want to send something back to the user. Yeah, and then I can see all the different logs. And this is the CloudWatch output. So the beginning and end and all the logs in between of the function it'll show me. And I can always look at monitoring too. So I can see how many times, I can see how many times it was invoked and also if there were any errors. And then I can set up an alert. So if my function errors out, or maybe I have a clock process that runs every week or something. So if it errors, I really want to get an email to tell me like, hey, it didn't work or something went wrong and what went wrong. So it can send me that. And from CloudWatch, I have more options to look at the metrics. They have logs here. Which one? Test hello world. So I can see the logs, which are kind of hard to read a little bit. So it's better if you make dashboards. I think it's better visually, so I can just quickly look and see. These are my Lambda functions. So it takes a few minutes to update, so it hasn't updated with my last invocation. But it can show duration, errors, invocation, and if it was throttled or something happened. And then I also have some information about, it's not too pretty, about my Dynamo tables. So if there was a problem, if there was some kind of error, I would want to know about it. And I could also set up some kind of message to alert me if there's an error with my Dynamo data, which doesn't happen too much with NoSQL. But yeah. So how this generally works is, which one? Okay. So I have kind of a core Lambda function which interacts with other services from AWS. Here I'm interacting with DynamoDB. So I'm getting an event from API Gateway where I created this REST API. So I can make a GET request to, Amichis are just like these little animals we created at this hackathon. These little animals, basically. Yeah. So the GET request pulls in all these animals from the database, all these animal objects, and the link to where the picture is stored on S3. Yeah, so I can either get a single Amici or I can get all of them together. And for configuring the API, you can create resources, which are the endpoints, or you can create methods. So get, update, post, put, delete, all those. And the only thing you really have to configure here is you have to hook it up with the Lambda, whichever Lambda you want to invoke when you invoke this, or when you hit this endpoint, you just say, hey, AWS, I want you to run this Lambda and pass whatever information if I'm making a post request or something. And then you tell it where you want. You can make a body mapping template to tell it where you want or how you want the data sent. So I always have, this is kind of hard to see, but I have the data attached to a body JSON. This body JSON inside the event object. So in my Lambda, I can access this by doing event.body.json and then get all that information and do whatever I want with it, interact with the database or pull whatever I want from the database. Yeah. So, and then, so that's pretty easy to set up, and then you can deploy per stage. So you can deploy in dev or prod or test or whatever, and then it will give you the endpoint for that stage. So see, the invocation URL will automatically, it gives you this automatically, and then /dev/Amicis. If I deployed in prod or whatever else, I could name it anything. It would be /prod/Amicis. Yeah. And then, yeah. And Dynamo is a really easy solution to configure too, because you basically have two options to pick when you create a table. You pick the name and a partition key, and then you can add a sort key if you want. It has other options like global secondary indexing and things, which I usually don't need. Sometimes I do need. And other than that, it's pretty much NoSQL, so anything goes. You can put anything in there. Yeah. So that's basically how the console works. And then I usually configure this. I'll upload the front end of the application to S3, which is their object storage. And I can either do this manually or automate it. I think, oh, right here. Yeah. I can either do this manually or automate it, and then also store any images or files along with the application. And then I'll set up notifications in their notification service, and then I can subscribe with my email or phone or whatever devices I want to subscribe with. So I get certain notifications based off messages sent from the Lambda or CloudWatch events, or however I want to configure that. But this gets a little tedious if you have a lot of infrastructure to manage. So if you're making a lot of different Lambdas, you have different S3 buckets, Dynamo tables, and a bunch of other stuff, and plus your API. So especially if you want to remove something or update it, it's like you have to update it across the board or remove it, and then remember to move every little piece, including the CloudWatch logs and everything else that was created. So there's a cool local, let me zoom in. There's a cool local way of doing this with a framework called the Serverless framework, and this works with AWS and Google Cloud, and I think maybe Azure now, I'm not sure about that. And basically, you configure your local AWS CLI, so you have to log in with credentials, and then you have to log in to serverless using a user. They tell you to use an admin login. Might not be a good idea. You don't actually have to, but their documentation says that. You just need access to Lambda, CloudFormation, CloudWatch, and a few other services. So yeah, you don't have to do that. And it gives you a template to build Lambdas off of. So I'm just going to copy this code. Oh wait, I have the final version. Nope. Here. Yeah. Yeah. So here's the template. And you can do the template in any of the 4 language Lambda supports. I'm just doing it in Node right now. And then I'm going to create a directory. I don't know. Yeah, and it will generate a boilerplate. Oops. Oh, I see. I didn't have. VS Code is so nice because the sidebar zooms in too when you zoom in, unlike Sublime and other things. Anyways, so it gives you 3 files if you use Python or Node. It'll give you your git ignore, and then this configuration YAML file. Let me get rid of this. So it does only pretty much the most basic setup. So it'll configure your environment and then a basic Lambda function. And then you can add as many Lambdas or other features here. The cool thing is that it gives you a lot of templates that you can just uncomment this. Like if you want to set up HTTP endpoints like a REST API, you can get started right away, just uncomment this and finish configuring. It also gives you CloudFormation template down at the bottom, which will configure other resources automatically for you. So if you want to set up Dynamo tables or some other kind of SNS or another Amazon resource, then you can configure it to automatically be created and managed from this configuration file. Yeah. So here's the basic Lambda it starts with. It'll give you, I don't need this part. Yeah. It'll give you a basic Lambda. If you're invoking this with an API endpoint, then you'll want to return in the response a status code and a body. I think it might throw an error sometimes depending on what you're doing if you don't have a status code on it. Yeah, and then you can basically import any modules you want. Some are built in, like you could import FS from FS as built-in node modules, or you can npm install and add any third-party module you want. And it'll automatically be bundled with your code when you push. And then it's pretty easy to deploy. You can do serverless or SLS for short. Deploy, and it will build and push your function. As long as you gave it a unique name, it shouldn't error out here. And then it will, any environmental variables or other configuration you set, it's automatically going to set that in your live code. But this takes a minute the first time. So I just have, yeah. I think this one, yeah. I kind of set some more roles and permissions. I can set the timeout, memory size of the function, what profile, user profile it's associated with, which will give it permissions. Yeah, and I set an environmental variable, which I can use in my Lambda function. Which one am I using? Yeah. So, and just like regular environmental variables, I can access it, process env, and use that inside my Lambda function, which is nice that then I can either set it from my YAML file or the command line, because you can also use variables in YAML. Which I think I have an example of. Yeah. So this is more of a straightforward to-do application. And then I'll show you how the live code looks. So this is using a nano services approach. So I basically have a function for each different method on the endpoint. Yeah. And then I can configure what access I have to Dynamo. So the function can query, scan, get, put, do all these other things that I'd need for a to-do application. And also I am provisioning and setting up this Dynamo table and setting some configuration options. And then I can configure multiple Lambda functions all at once, and these all get created live. But this takes a little while to set up for the first time, so I already did that online. Oops. No, it's here. Yeah. Here. So when I ran that function, it gives me, it's me serverless REST API with Dynamo, dev delete, create, update, list, and get. It gave me each of these different functions. And then it also created, where is it? Okay. It also created a Dynamo table for me automatically using the CloudFormation syntax. So I have a Dynamo table, and I can set up different metrics or alarms from serverless as well. And I can also set up keys and indexes and things like that. And then it sets up an S3 bucket automatically where it uploads the code to. I've done so many of these, I don't know which one it is. I think it's in here. Yeah. So it'll upload a version of the code when I upload. You can turn this off if you want to, since you'll probably be putting your code in Git anyways. Yeah. And then, it also created my API for me. So my to-do API, it automatically knew that they're all called to-do, so I'm going to put them in the same endpoint, get and post. And then when I pass the ID, I can use delete and get also for individual to-dos or put. Yeah, so let me see if I have any more. So the serverless blog is a really good way to stay up to date on serverless technologies. And then this is the thing I'm really excited about, the SAM local. And it was just August 11th. And I heard rumors that this was going to come out, but I didn't have time this past weekend to test it. So it's basically going to let you test, debug, do all kinds of things locally, and they're going to keep adding features to this, which sounds really, really cool because it was always a little bit difficult for me to test locally if I was using other AWS resources in the serverless architecture. And one more really cool new thing that I'm going to use next time, actually next month when I start a new application, is step functions. So this, there's an example here. Yeah, so when you're building serverless, sometimes you have all these different functions and microservices and everything, and you're trying to connect them together. And then you have triggers for this, and this triggers this, and it can get kind of complicated. So AWS, I think it was very recently that they came out with this project called step functions. So it'll let you configure your serverless, architecture and see it visually in like graphs, and you can kind of see like what triggers what and stuff. I'm not sure the pricing. This might be another one of their free services because you use other AWS services kind of thing. But yeah, this is a really cool and good idea. So yeah, and then this is the gist for some serverless commands, but you can probably get the full list of commands laid out much better on the serverless blog if you want. Do you guys have any questions? Yeah?
So I wanted to ask you, what do you think will be the difference?
So I can test functions locally because, where is it? Because serverless does have the serverless invoke function, but I feel like I can't use all the different parts of the ecosystem of AWS. So I can stream my CloudWatch logs while I'm testing the function and mocking some things up, unless you know of a better way to do that. So mostly we used it to build a series of Lambda functions for APIs and backends. And then for Alexa applications, we did some of those. And then clock processes, because it's really easy to configure. You can use the cron or whatever syntax or another syntax to make it invoke at a certain time. And then you only have to write the code. It's not like you have to write a whole server or something. And it was a lot cheaper because like we had a client who was doing it on Heroku, and they were basically charging like more than 10 times as much for the same thing, and there was more configuration and more pain. Yeah. Yeah.
So what kind of Alexa applications did you build?
What?
What kind of Alexa applications did you build?
Oh, it was some internal applications, and we built one for a client in California who was in the medical field. I signed an NDA for it. I can't talk about it. I haven't shipped any myself. I have some locally at my house. Like I've been wanting to finish building this recycling app and some other things, but I just haven't had the time yet. Yeah. Plus Alexa has gotten a lot better recently. So.
The example that you presented here, you said.
Oh, I was at a hackathon, so I set up a new account so I wouldn't ruin anything in my main account, because I have some client functions in my main account from consulting.
Any S3 charges or anything for this particular example then?
No, I'm still on the free tier. I think my biggest bill ever was like $8 or something. It's so cheap to use some of these things unless you're in the millions and millions of invocations. And even when I have to pay for indexes and extra things in Dynamo, that's still really inexpensive. It was actually much cheaper than, I had some droplets before, and then I moved everything to AWS, and it was so much cheaper in AWS. Okay, thanks for listening. Sure.